All right. I'll try and keep it lively. I'll randomly like scream into the mic. No, I'm just kidding. Ah! Just to
Or you
make
could
sure you're
just
awake.
like,
Yeah! There you go. There you go. Or I could like, yeah. My brother was trying to teach me how to make armpit farts with my armpit. Can't do it.
okay, no, please don't.
Or like, or do one of those things where in like public school where the bell would literally ring into your ears
Right.
and be like, "Oh, okay, now we need to go to the next class."
Oh yeah. No, I have that really annoying ringer there. Okay, so first thing we want to talk about is we want to kind of review the coordinate plane a little bit. So what I would like you guys to do, because most of you kind of know about this, some of you, might have an idea, but are just like, I'm not sure. I would like you to label some of these things on the coordinate plane. And remember, guys, we want to try and keep it pretty easy to label. I feel like this person was just trying to point it there, but I'll explain how we want to do it and all that good stuff. So first thing, let's talk about the quadrants of the coordinate plane. So where is quadrant 1? Can I have someone label that? And quadrants, yeah, you got it, totally. That is quadrant number 1. And a good thing to put in your notes would be this coordinate grid, guys. This would be good to write in your notes, the x and the y axis. You don't need to copy all these little squares or anything. But it would be good as a nice review of the parts of the coordinate plane. So this is quadrant 1. This is where the x value is positive and the y value is positive. Where's quadrant 2? Yup, exactly. This is where the x value is negative and the y value is positive. What about quadrant 3? Oh, very good. This is where both x and y are negative. And then that is quadrant 4 down there. Very good. This is where x is positive, but y is negative. Good. What about the origin? Oh, someone labeled some stuff there. Where's the origin, guys? Yeah, very good. Very good. Someone's labeling x-axis. That's perfect. This is the origin. This is the coordinate point of 0, 0. That's kind of where you want to start when you're plotting all of these points. Good. We got the x and y axis labeled. X is horizontal, y is vertical. Remember, the left side of the x-axis is the negative x-axis. The right side is the positive x. And then the top side is positive y, bottom is negative y. Good. And what's important to know about all of these coordinate points is it's always x first, then y. So you're always going to go right or left first, then up or down. Sound good? Questions? Any questions, my friends? Everybody remember that? Yeah, very good. Someone put a sample point on there. That's absolutely correct. If you have the point -2, 1, that would be like saying to the left 2 and then up 1. Good. Nice job. Okay. So let's have someone please plot the point 4, 2. 4, 2. Very good. Yeah, exactly. This is the point 4, 2. It's to the right 4 spaces because it was a positive 4 in the x value. And then it's up 2 spaces. Good. That's 4, 2. Perfect. What about the point -3, 5? Where would that be? Very good. Yeah, it's going to be to the left -3 and then up 5. Good. Very good. Good stuff, amigos.
This was actually my favorite part of math.
I know.
Besides graphing.
Yeah, I loved doing this stuff too. Okay, there's no triangle here.
I like slopes.
Oh, good. We'll get to that next semester. Woo! So, okay. I need maybe Aiden, Cece, Layla. Can you put 3 different points
I'm
on
special?
the graph? I just picked 3 random, but yes, you're special.
Aw, now I don't feel special.
No, you are. You totally are. Totally are. So Aiden, Layla, and Cece, if you can pick 3 points and just put it right on the grid. Okay, there's 1. Right on the grid. Like someone put a point down in quadrant 3. That's good. Okay, that's another one. Oops. Oh, and we don't want, well, we can label that one. That's fine, but we don't want to label it. Just because. I said that
That
really
kind of gives away the answer.
Yeah, it does, but that's okay. If we're as sleepy as I am, nobody saw. Okay, so we got a triangle here. Thank you guys for doing that. So
For a second it was the
now,
Verizon symbol.
oh yeah, you're totally right. That's crazy. I have Verizon too. Good stuff. Okay, so now those who did not put the points on there, I need people to label the points. So let's label the points. So don't label your own point that you did, but you can label the other points. So we want to find the different points of the vertex. So we'll call this vertex A, B, and C. So we want to find where those are. And remember, this is positive x, this is negative x, positive y, negative y. Okay, so someone thought that C was at -5, -4, 1, 2, 3, 4, 5. Good. Yep, exactly. And guys, look at how they put parentheses around their ordered pair. Very good. X is 2. Someone thought 7, someone thought 6. That's why I'm glad we're doing this. I love that. 1, 2, 3, 4, 5, 6. I did get 6. Yeah. Oh, no problem. Hello, Connor's friend.
No one has solved mine.
Yeah, what about point B? Sorry, I'm getting all jumping ahead of the term there. So that one we would say is 6, 2, 6. What about B there? B for Bob. Yep, I totally agree with -4. It's to the left, -4. And then down to 7. Let's see. 1, 2, 3, 4, 5, 6, 7. Yeah, very good. That's funny. This is Bob, Cal. This is triangle Aiden, Bob, Caleb. Very cool. Very good, guys. Any questions on that? Remember, it's always X first and then Y. X and then Y. Thanks for the assistance there. I have not. I got a glimpse of it, Connor, when you had it earlier. Nice. Look at that. We got a rock star over there.
It is an Ibanez.
I would not know enough about. I know that those guitars are gorgeous. Not like that specific, but they're gorgeous.
Oh, Les Paul. These were made in like the 40s.
Oh, I've heard of that kind.
Les Paul was a person. He was a jazz guitarist.
Nice. Very cool. Was that a Christmas gift?
Yeah.
Nice. Math. You are right, CC. We've got a lot of math going on here. So what this is saying, no need to sit and copy all of this, but what it is saying is that the distance formula is a formula that tells us how to get from one point to the other on the coordinate grid. It tells us the distance or the length of a segment. But if you take a segment and turn it into a right triangle, all it is the Pythagorean theorem. So it's the same thing. Okay, so we're going to talk first about turning our segment into a triangle, a right triangle, to do that Pythagorean theorem. But the formula that you are going to want to get down, oh, not that one, is this distance formula right here.
Get down,
get funky. No, I'm just kidding. This is the distance formula you guys will be working with today, and it definitely
this is not
helps.
disco math.
Just see, it's D for disco. No, D for distance. But if you get it in your notes, it helps to have it in front of you while you're doing your homework. It really does. So D for disco. Disco formula. Da, 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 da. Sorry, I'll stop.
Do the hustle.
Yes, Callie, you're so right. And you know what's crazy is you might not see how you're going to use this exactly in your everyday life, but sometimes working through formulas and figuring it's kind of like a way of thinking. You're training your mind to get into. Also, you know, depending on what you get into, you will use this. My brother, I know I've talked to him about him before. Gosh, he uses a lot of stuff with coordinate planes and trigonometry and algebra in his video game design. Fractions? Yeah, fractions are pretty huge. Yeah, definitely. They are used a lot. I've even used proportions and stuff in cooking. But that's just because I am a nerd and I need to write everything out. I guess that really doesn't make me a nerd. Aiden, that's a good comment. I like that. All right, so we have the distance formula. So we're going to do some examples. So, okay, when you have a segment, so the reason that we're kind of looking at this is we want to figure out how long this segment EF is, okay? And now what we can do, we have two ways we can do that. First, we can say what the ordered pairs are. We can give the coordinates and then put it through that distance formula. But another way we can do it is just to turn it into a right triangle. Because whenever you have vertical and horizontal lines, you just have to count the spaces. Okay, and I can't count the spaces on the diagonal line because, guys, look, it's not really crossing there. Yeah. Oh my goodness, sorry. That's totally right, though. We would definitely excuse me. We would definitely draw in the triangle and use it to help us with this distance there. So what would I say is the length of this vertical segment here? of the triangle. What would this length be? How many spaces is that? What do you guys think? And you're just counting the different spaces. So I counted this one and I got 7. Yeah, and it looks like, right, and this is where it gets confusing because if you count the spaces, you can't forget where it starts right here. So we would actually start here. We would go 1, 2, 3, 4. So we would say this segment or this side of the triangle is 4 units long. So you're going to start, yeah, and then the one on the bottom would be 3. You're going to start on the vertex and then count until you get to the next vertex. Good. So now, instead of doing that big long formula, I can just put this through that Pythagorean theorem that we talked about before, where we take our leg, so 4, and square it, and add it to the other leg squared.
Leave
And
my
then
leg alone.
we're going to square it. And then we're going to find the square root of that. So what's 4 squared and then 3 squared? What am I really adding here if I do that Pythagorean theorem? No,
That
I
would be
would
a
never.
problem if I didn't have a leg.
That would.
Because you already took my other one.
We did, because we've done a lot of Pythagorean theorem.
When will it end?
Never. I'm just
When
kidding.
will my leg have peace?
Okay, so guys, what's 4 squared? What would I get here? 4 times 4.
That is 16.
Yeah, it's not a whatever you wrote there. No. And if you're like me and you're like, whoa, squishy brain today, I am tired, it's a really dismal day, then you know what? You can totally go to Desmos, because Desmos really is a nice calculator to help you do that.
Even though I don't know how 4 times 4 is hard, but okay.
Right. It
I'm not gonna
isn't.
question.
Yep, it isn't. However, sometimes you're tired and you're like, oh, 4 times 2. Or you just, you want to type it in. Because Desmos is pretty cool because you can type the whole thing together and it'll tell you what it is. You get 25. And then you can take the square root of that 25 and you get 5. So we find out that the length of that segment EF there would be 5. But you're right, all we're doing is we're going 4 squared is 16 plus 3 squared, which is 9. That gives us 25, and when we take the square root of that, that gives us that 5. So we can do the distance formula, or we can do the Pythagorean theorem. Kinda is up to you. Either way is okay. If I were you, I would do Pythagorean theorem if it's on a graph like this. If it's not on a graph, I would use the distance formula. Are there any questions with that last one there? Any questions?
Do we really have to use my leg?
For this one, we do. Sorry, Aiden. Give it up. No, I'm just kidding. Okay, so for this one's
Creepy.
I am good at that. Yeah. So this one is on the grid already. So let's go ahead and let's draw in perfect the triangle. And you could do the triangle either way. You could draw it how our person drew it right there, or you can draw it above. Doesn't matter. This is perfect. So why does it say Amy Whipwrote on there? Oh, weird. Yeah, did you guys see that?
That was creepy.
How did that happen? Oh, wait, I'll go back.
She's stocking our garbage again. Everyone run!
I'm gonna have to
Run.
tell her.
invade us.
I'm gonna tell her.
Run.
I'll be like, Amy, your email randomly showed up on. She'll get a kick out of that. So okay, so we have drawn in our triangle.
She
Now
is with us spiritually.
always making sure that we dispose of our trash properly, right? Steal our trash. I like that. Okay, so let's label those legs. Okay, what would I label this vertical leg here? How long is this guy?
6.
Let's see. 1, 2, 3, 4, 5. Yeah, I totally agree. Do you guys agree? Definitely. And I appreciate that person labeling kind of how we count it. That's good. What about the horizontal leg? I appreciate the labels, but I think we forgot a number down here. 1, 2.
Oh, I'm dumb.
No, you're not. No. No,
I don't
no.
even know how I forget 3.
No, that's
You're just possessed by a teacher. Don't worry about it.
It was Amy. Oh my gosh, she made you do that. She possessed your arm and made you forget about 3. That Amy. So we would say then that this horizontal leg is 4 spaces. Now we need to put it through that Pythagorean theorem. So guys, go ahead on your own. Put that through the Pythagorean theorem. Remember, you're going to take 6 squared and add it to 4 squared, and then you're going to find the square root. Oh, no way. No way. You're the heart and soul here. We need you. And you will get a decimal here, and that's okay. We'll round it to the nearest 10th. What do you guys think? What would be the length of our hypotenuse there? Or would someone write on the screen what my Pythagorean theorem would look like?
Well, the answer would be 52. But if you rounded that, that would be, I think, 50.
Well, you're right. You would get 52, but we got to make sure that we do that final step of the Pythagorean theorem. Excuse me. So what do I have?
Oh, yeah, that's right. I just remembered.
Yep.
Jeez, I should
root it.
really go back to kindergarten.
Oh, this is not taught in kindergarten, my friend. My daughter's in kindergarten. She's...
You never know. They're building businesses in that kindergarten.
That is true. She does think she knows much better than me. And who knows, she could. Okay, so we take the square root of that 52, and what do we get? What do you guys think?
And you pull out dominoes.
Dominoes. What do you guys think? Did I lose you on what we're doing here?
Well, I guess it would be 7 because the thing is like super long.
Yeah, you're right. We would actually round it to the nearest 10th, so we would say 7.2.
I don't think a leg should be in the decimals, but okay.
Well, that's a hypotenuse, so it might happen sometimes. You're right. And sometimes it is very inaccurate to represent it that way, so sometimes what they'll do is they'll just leave it as the square root of 52. Oh, no. Okay, questions on this. So that's one way to do the distance formula. The other way is to use the actual formula. And this is where you guys might want to write this down. The distance formula tells us to take the second x value and subtract the first x value and square it. And then we add it to the y values subtracted. Guys, make sure that you watch this. This does show up in geometry and linear algebra and all that good stuff. So for this formula, we need coordinates. Can I get someone to write what the coordinates are of my endpoints here? What are my coordinates here? Okay, we've got a 2, 3, and a -2, -3. Perfect. Okay, so now we got to figure out what's x2 and what is x1. x2 stands for one of your x values, x1 is the other one. So which one should we label as x2 out of these coordinate points here?
Probably label the one in the negatives.
Sure. Yeah, and I'll tell you, it doesn't matter which one you call x2 as long as you don't use a y value. So one of these will be x2. Which one? One of these.
The -2.
The -2. Yeah, we're going to call that one x2.
You can't trick me this time.
Could we have called the 2 x2? Could we have done that?
Yeah.
Yeah, we totally could have.
Doesn't matter.
Does not matter. But we have chosen this guy as x2, so that means this 2, this +2, is going to be x1. And what about y2? Which one would be y2 then?
The -3.
Yep, very good. Since we chose -2 as x2, -3 is y2. And that means this one is y1. And then I'm just plugging it into the formula. So wherever there's a x2, what am I going to replace that with?
-2.
Yeah. Very good. Is everybody else still alive out there? I know Aiden's alive.
Does anyone else have legs?
Gerta Goblin.
Aiden's alive because he's thinking about Domino's.
And pizza.
And pizza.
And then, like,
Good.
decimal legs.
Decimal legs. Good. I'm glad we're okay there. Okay. So now we got to simplify. You could totally just type this all into Desmos like that, by the way. But we're not going to do that. What is -2 minus 2? What would that be?
0.
If it was -2 plus 2, yes. Remember, -2 minus 2 is the same as -2 plus -2.
That'd be -4.
Very good. And what about -3 minus 3?
-6.
That's right. That's White Webbit. Okay, and what about -4 squared? That's -4 times -4. What would that be?
Would that be 8?
That's
Or
that's 4 times 2. We want to go -4 times -4.
or is it -8? Oh, wait,
No.
no. I mean, I'm not dumb.
Of course you're
It would
not. No
be
way.
-16?
Positive 16. It would,
Positive
because
16.
negative
Okay,
times
never mind.
negative
I'm dumb.
positive. No, don't say that. No way, friend. And what about -6 times -6? What's that?
To Desmos.
To Desmos. We could do that. Let's say we get to this point and we're like, I'm tired, man. I'm done. I'm done with this math stuff. We can do that.
Wait,
We
I
can
forgot. I
go-
bookmarked it.
Yeah. We can do that. We can go to Desmos. You could type it in right from there. Or you could just do -6 times -6. That works.
I've made too much dummy answers. I
Equals
need
36.
Desmos.
Very good. No, never, never. That is 36. And then we add them together. We get the square root of 52. And then we take the square root and you get that 7.2. So it's the same answer either way.
But
Whether
it's
you
just
do-
painfully long.
It is. It's a lot longer this way. I totally am an advocate for using the Pythagorean theorem. And if you guys get a graph like this on your homework, you can download, if you have Google Chrome, you can download WebPaint for free from the store, from the Google store. Or if you don't have Google Chrome, you can download Epic Pen. It's pretty cool because it's a free way to write right on your screen. So you guys can use Epic Pen or WebPaint and draw in those lines to help you. And if you want help downloading any of that, you just let me know and I will help you. So yeah. No. Okay, so I think we already did this one actually. We did it on a different slide. So we'll practice with the distance formula for a sec. So here's the formula again. Does anybody need to copy that down? Does anybody need it? Nope. Okay.
No.
Okay, so this one, oh, we already did the distance formula with that one. Okay, we'll do it with this one. I was getting ahead of myself, guys.
I don't want to do the same question twice.
Right, why would we do that? No way. No way, friends. Okay, so I believe this is our last example. Yeah, so just stay with me for this example and then you are free. And it's still early, so we got this. So here's our distance formula. Tells us to subtract the x's, square them, and then add it to the y's subtracted and then squared. And here's our points. We have r is -2, 5, and s is 3, 7. So of those points, which one would you say, these are our 2 points here, which one is x2?
This time it'll be 3.
3, yeah, I agree. It's the second x value, so we call it x2. And what about x1?
-2.
Yep, very good. And remember, it's completely up to you. You just got to pick the x's. So we'll enter those into our formula right away. Yeah, this isn't the greatest formula. It's kind of putsy.
Kuna takes my legs. Like, I didn't ask for it.
So x2 minus x1, we're going to go 3 minus, notice how the minus is there. It's part of the formula. Now we plug in, yep, good, the -2. Very good. And what about y2? Which one's our y2?
7.
7, totally our y2. Very good. And y1 is the only one that's left, which is 5. Good. And someone filled in the y1. Very good. And we got to fill in the y2, which is, I don't know if person's filling it in, but I will. Oh, someone did. Okay. 7. Good. And we could completely go to Desmos and type all of this in. You would just have to, and I'll show you. You just got to be careful to type it just how it's written. So we would type in the square root, and we're going to use parentheses, 3 minus -2 squared plus 7 minus 5 squared. And you do get a decimal, and it's 5.4, we would say. And if Desmos does not want the decimal, sometimes they'll say simplest radical form, then get rid of that square root. And you see how all that stuff under the square root equals 29, then you would just leave your answer as the square root of 29. So, Desmos it up, my friends. Desmos is where it's at. Did I erase that too quickly? Does anybody still need that on there? Because I can undo.
I feel like no one else is here, so
I know, you guys are so quiet. Did I lose ya? It's a lot
Because
of
no
boring.
one's laughing at my
I'm
comments.
still
of booger
here. I'm
flakes.
just half awake.
Oh, I get it. It's a sleepy day. And now I want booger flakes. No, I'm just kidding. I don't. That's really gross.
Ew.
And yeah, I just want to make sure you guys get it. It's not bad. It's just very clunky. There's a lot of calculation. So what I'll say is I will let you go. We are early. Whoop, whoop. And
Sweet, nap time.
if I were you, I would go and get this assignment done right away in Math Excel because we just went through it. So that's
After
what
nap?
I would do. But you are free to go, my friends. If you want to hang out, if you have questions, you are welcome to. But you are free.
I'm up for hanging out.
All right.
Going into the
Bye.
Discord.
Bye. Have a great day.
I
I'm
just found
gonna
this
have
meme.
nap time.
Oh boy.
I just found this religious meme, but I found it funny.
Let me see.
It goes, me, God, who created you? God, what? No one. Me, so you believe no one created you? God, yup. Me, so you're an atheist. And it shows Tom and Jerry, the Tom and Jerry thing.
Oh geez. That's one of those like make you think memes there. Some of those memes are like modern day political cartoons.